Yeah, sure. So everybody, thanks for showing up. This is Mark and Kevin from the Northern Jersey Astronomical Group. They're a local organization of bona fide astronomers at all different levels of expertise, and they have regular meetings. And it's a club that anyone can essentially join. And not only do they have these very interesting discussions on a monthly basis about space-related topics. Some of them are pretty dense, might be more of upper level, but it's still fascinating stuff that you could participate in. But they also have these outdoor viewing events that they organize on a regular basis. Just in fact, last June they viewed that solar eclipse that happened early in the morning, in addition to comets and other types of cool things. So I'm very grateful that they agreed to do this on a regular basis to bring to you this opportunity to view the heavens in a way that maybe you've never seen before. If you've been to a planetarium, this is a little bit similar to that. And they have a ton of knowledge. They're willing to answer your questions, entertain any questions you have to try to answer them. And hopefully we'll be able to meet in person, if weather permitting. One of these days, we'll continue to plan events. Since we can't meet in person today and see actual live events, live things in the sky, what Mark and Kevin have for you is a series of clips from past events that they filmed at this similar time of year. And what that means is the things that they're going to show you are the things that are actually up there tonight. And this is what they would generally look like this time of year, but you just can't see them right now because there's too many clouds and rain out there. For those of you who don't know, the things in the heavens do rotate like the sun does and the moon does. They move through the sky. So where they are right now, they won't be 4 hours from now. And in a month from now, they'll be in a different place. So they constantly move as the Earth orbits through the Milky Way and the universe and all solar system and all that kind of stuff. So things that you see in December, you don't see in June and vice versa. So with that, thanks again to NJAG for coming to do this with us, and looking forward to some really cool stuff tonight.
Great, cool. Well, thanks for that introduction, Dan. We're going to start out with a little virtual stargazing here, since it's so cloudy outside. We're going to take a look at the sky using a bit of software, which is called Stellarium. And you should be able to see on your screen a view of the stars as if we were outside right now facing the northern sky. And so this is some of the stars that we would have seen if it were clear out tonight. And so we're facing north, and I figured we'd start out with the northern sky because some of the patterns in the northern sky are very familiar to people. And so, for example, a lot of people know the shape of the Big Dipper. And so if you look at this view of the northern sky, look around and see if you can spot the Big Dipper here. There are, if you've ever seen the Big Dipper, you know that there are 7 bright stars, and they're in the shape of like a spoon or a pot with a long handle on it. And look around and see if you can spot it. If you haven't seen it yet, that's not surprising, because this time of year it can be a little bit difficult to spot. It's very, very low this time of year. In fact, it's so low that part of it, the handle of the Big Dipper, is scraping along the northern horizon at this time of night. And so look down right over here, you should see my little arrow, my little cursor here. You can see the 7 stars, or at least 6 of the 7 stars of the Big Dipper right here. They're very, very low in the northern sky, and the 7th star is down here in the trees. And as I mentioned, yeah, these stars really kind of drag along the northern horizon there this time of year. So if you go outside and you can't see the Big Dipper, don't get frustrated. It's probably hidden behind some trees or a building or something like that. And you have to wait till a little bit later at night to get a good view. So just keep that in mind if you go outside. Look for the Big Dipper down low in this part of the sky. And so there's the 7 stars of the Big Dipper. They are also known as by their official name as Ursa Major. And you may have heard of that. Ursa Major is the Big Bear. And so this is Ursa Major, the Big Bear. Here you can see the 7 stars in the Big Dipper are part of Ursa Major. And those stars come in handy. You can use the 2 stars right here at the front of the Big Dipper to help you find the North Star. How do you do that? Well, take those 2 stars and draw a straight line. Imagine that you're drawing a straight line in the sky like this. If you follow those 2 stars, follow that line, you'll run into this star right here, and this is where you'll find Polaris. So this is Polaris, otherwise known as the North Star. And you can see why we call it the North Star. It's due north of us. No matter what time of year or what time of night you look at it, it's always right here in the sky, at least from here in New Jersey. It doesn't really move. And so it's almost directly above the North Pole of the Earth, and that's where it's pointing. And so as the Earth is turning, the sky seems to turn, and it's all kind of spinning around this star. It doesn't seem to move very much. And so it comes in very handy for navigation. If you know where the North Star is, you know that you're facing due north, and you can figure out the directions from there. And there's north, and you'll notice that there's another familiar pattern here. You'll see that the stars here by the North Star also look like a dipper, except for it's much smaller and fainter, and that's what we call the Little Dipper, otherwise known as Ursa Minor. So you've got Ursa Major, the Great Bear, Ursa Minor, the Little Bear, and so they're, at least in Greek and Roman mythology, they're thought of as these bears in the sky. And so there they are in the sky. But most people just look for the 7 brightest stars inside of those constellations and call them dippers. And so there's the Big Dipper and Little Dipper inside of Ursa Major and Ursa Minor. So those are good landmarks to look for in the night, so to speak, in the nighttime sky. Let's see. Mark, do we want to start out with the Veil Nebula again, like we did last week?
Yeah, we could. It's still high enough.
Yeah.
high enough of the ring. So, I think might be too low. So I don't know if you want to.
Yeah, maybe, but we could still show it, I suppose.
Sure. Yeah.
Well, let me show you what Mark has a picture that he had taken earlier this summer of an object that's located in a constellation that usually thought of as a summertime constellation, but it still hangs around. It's far enough north that hangs around all the way through December. And you can see it in the northwest part of the sky. You've got a fairly bright star here called Deneb. And this is part of a constellation which is known as Cygnus. And so this is the constellation Cygnus, known as the Swan. So this is Cygnus the Swan. The Swan also has a nickname. Sometimes it's also known as the Northern Cross. And you can see why. You know, there's a big cross or plus sign shape there in the nighttime sky. But it's traditionally thought of as a swan, big long neck and its big wings spread out on either side. The bright star Deneb is the tail of the swan. And so the object that Mark is going to show you here in just a moment is located not too far from the center of the constellation here. And it's rather faint, but it's a pretty popular object for amateur astronomers to image and to look at with large telescopes. And so, Mark, do you want to share your screen here? Let me stop my sharing. There we go.
So before I will go in here. Oh no, actually, you know what I need to do? I need to, okay, now, let me stop that and close and reopen. Did it open it? No, it did. Good. Got around the little hiccup from the other night. So before I even go into the video, this is just a still picture of one piece of the Veil Nebula. So this is in that same area in Cygnus, and you can see all these stars that you see here are in the foreground. They're closer to us, and the nebulosity that we see here in the background is way back in the background, many light years more distant. But all this gas that you see here, this was a supernova explosion somewhere between 6 and 10,000 years ago. They're not quite sure on the exact age of that, but a star had exploded and it blew off all this gas and dust. So I'm gonna stop the share and go find the actual video. Give me 1 second.
By the way, while Mark is looking for his video, remember that a nebula is a big cloud of gas and dust out there in space. And so this is one type of nebula that we can see in our telescopes.
All right, I got it.
I guess just as a reminder, if anyone does have any questions about any of these objects as we're going through them, you can use the chat, or I guess you could also unmute your microphone as well if you want to ask
Here we are.
question in person too.
Okay, so here we're just building up the image. So
remind me, Mark, what size telescope was this taken with? Do you recall?
This one is with the telescope I no longer have. This was with a 14-inch Skywatcher Dobsonian.
Okay.
So
it's a 14-inch diameter. The mirror on that telescope is 14 inches in diameter. So it's pretty good size.
Pretty good size. But even a smaller telescope can do similar. You just have to expose the image for a little longer. It's the only difference. So what's happening here is, if you look down at the bottom of the screen, you can see how long the exposures are. And so these were 5 to 10 second exposures, and they're laid on top of each other, one after the other after the other. And you can see as they stack, the image seems to be getting more detailed, more contrast. You're seeing more of the image pop out at you than otherwise would be. So this is the equivalent of the shutter being open for a longer period of time and just soaking in all that light over time. You can see now all the wisps of the nebulosity are starting to finally come out. So that light is so dim that it takes the camera a certain amount of time to absorb it. And so it has an advantage over our own eyes, because our own eyes can only see in real time. The camera can take that and then stack all that, what it's seeing, over 5, 10, 20 minutes, an hour, so the longer you expose it, the more data, or the more detail you'll see. So that's the beauty of doing it this way. Plus also a camera will also allow you to see in color, where the human eye can, the human eye can only see in black and white for the most part, because faint objects, dim objects, you need to be in utter darkness, and your rods are kind of like your night vision. So you're activating your night vision. So you're not seeing in color, so to speak. The object's not bright enough to see it in color with your eyes. So that's why a lot of people, when they look through an eyepiece, oh, it looks blue, or it looks gray, or maybe they might get a tiny hint of green, but there's not enough light coming through the eyepiece to activate the rods, the color sensing part of your eyes. And so that's the beauty of having a camera.
Hey, Mark,
sorry.
Hey, Mark, I had a good example of that just the other day. I was in the parking lot of a supermarket, and we were walking back to my car, and it was pretty dark. And I went to get into the car, and then realized that it was the wrong car. It was the exact same model as mine, but it was blue, and my car is green. It was dark, and I couldn't see the color, because our night vision really not very good at seeing color. And
color, right?
So something like this, it does bring out the colors that our eyes can't see.
Exactly that. But going back to the actual object, if some of these nebulae, you look at them and they're very small, the veil takes up a pretty big part of the sky. And the reason for that, when we said previously that this explosion happened some 6 to 10,000 years ago. Well, what happens when an explosion, it spreads out. Like if you drop a rock into a pond, you see the waves spread out over time. And the longer you wait, the larger that ring gets. And of course, the smaller that ring gets in the distance too. So as it spreads out, the gas becomes more and more diffuse. It starts to get harder and harder to see. So you can actually track this back in time. You can see this arc right here, right? So it's kind of curved, which means if it's curved like this, which means the center of the explosion was up towards the left-hand top of the screen here, that the gas is going this direction towards the bottom right-hand side of the screen. So that if give you some kind of perspective how big this has become, gives you one of the clues, the hints that this happened long ago and wasn't that recent.
Yeah, we're talking about at least 10,000 years. And the star that this originally came from was probably about 20 times more massive than our sun. So it's a pretty decent sized star.
Very,
And by the way, this nebula is about 2,400 light years away from us.
Right.
So it's
right. So the light we're seeing is 2,400 years old on top of that. So already so you add that on top of that, in reality, this is, if we were to visit it today, this would have spread much further. Perhaps it would even be off the screen right now. It'd be much larger. The nebula would be much larger than we're seeing it today. Any questions, guys? Let's see one thing in the chat. Oh, okay. I'll stop my share, Kevin, so you can go to the next.
Close
that down.
Okay. So let's see. Where do we want to go next, Mark? What's our next target? Do you want to?
So the ring is small. I don't know if you want to go do the ring or the dumbbell, or what do you think?
Sure. Yeah. Well, certainly the ring nebula, at least, is above the horizon at this point.
Just barely.
Yeah. So this next constellation is very tiny, and right now in the early evening, it's setting in the northwest. So this is a bit tough to spot this time of year, but we'll point it out because it just is such a nice object. The bright star you see here is Vega. It's even brighter than Deneb. You have this very bright star, Vega, and this is part of the constellation of Lyra. So this is Lyra, and Lyra in mythology is the harp. And the harp belongs, in some stories, belongs to Apollo, the sun god. And so here is the harp shape. And what you look for is you've got this bright star Vega, and you've got these, let me zoom in here just a little bit so you can see it a little better. You can see that it's kind of just like go ahead.
You're showing us Cygnus right now.
Can you
Vega's
see Lyra?
off to the right. From what we see, Vega's off to the right. I don't know if it's something different on your side or not.
Did your screen freeze, Kevin?
That's odd. It's not frozen on my end. Let me just go back.
There's some blank spaces actually here too.
You had the there you go. That's it. Now we can see the heart. Yep.
Okay, maybe it updated. So I've zoomed in a little bit now onto the harp. And so you've got that bright star Vega, and you've got 4 stars in a little box. And so you have to imagine that as the frame of the harp. There's strings stretched across that frame. If you want to play some music, you could pluck those strings. And so that's the harp. And the object that Mark is going to show you is right down at the bottom of the constellation of these 2 stars right here. And if you look about halfway in between those 2 stars, there's a little fuzzy point of light there that is an object called M57. M57 in the Messier catalog. You'll hear that mentioned a lot in amateur astronomers will use that a lot. They'll refer to M objects, and those are part of the Messier catalog. Messier was a French astronomer back in the day, a couple hundred years ago, made a catalog of interesting objects in the nighttime sky with a small telescope. And so a lot of those objects in the catalog are some of the nicest objects in the sky. And so we refer to them quite a lot. Mark, are you ready with your...
Sure. Yeah, I'll go and do the video. What you might want to do on your end while I share my video is maybe close out Stellarium and restart it because it is freezing a little bit.
Yeah,
Maybe that
that's weird.
it is a little hiccupy.
Then it was actually going to show the light. You said,
So, now we're going to see the telescope move. The telescope, see the star zooming across the screen here? The telescope's actually moving. And here comes the Ring Nebula into focus. And you can see it's a much smaller object than the supernova remnant we just saw. This was once upon a time a sun-like star, about the size of our own sun. It turned into a red giant, it moved off the main sequence, and then it collapsed a little and then got a little larger. And then, at the very end, it puffed off its outer layers. And that gas shell is now expanding in space, much kind of in the same way that we saw the veil, but much less explosive. And at the very center of that is a white dwarf star. And once this gets centered, I'll move this a little bit further. There we go. Then you can see I'm zooming in over here. Here's the nebula, right? And right, that little star in the middle there, with both cursors are pointing out, that's the white dwarf star in the center. And so the ultraviolet light that is radiating out of that, glowing ember, because it's essentially glowing ember of what the solid core of that star is now irradiating or illuminating, exciting the electrons, however, in the nebula cloud, and it causing it to glow in that matter right now. So there's a famous Hubble picture of this object, and it's much more detailed and close in than what we're seeing here. And this was out of, believe it or not, this is out of a little 8-inch telescope. So an 8-inch telescope can show you a lot, believe it or not. So I'll zoom in a little further and let the exposure get a little better. And you can see now in here. So there may be a solar system with planets inside this ring here. So we don't really know, but they're now, picture 4.5 or 5 billion years in the future, our own sun's fate, our own solar system's fate is going to be something very similar to what we see here. So at some point in the future, we're kind of looking into the past, but also looking at our own future one day will look like that. Kevin, do you want me to show them the dumbbell while I'm here too?
Yeah, because I haven't gotten Stellarium to reboot yet.
No, that's fine.
So
I'm gonna.
By the way, though, it's important to mention that when Mark mentions that this is the future of the sun, remember that the sun will never go supernova. The way that that other star that we showed, the Veil Nebula, that's the result of a supernova, a star exploding at the end of its life. And that will never happen to our own sun. It's too small. It's just really too small for that. And so it ends up like this. It ends up like one of these nebulas that we're showing.
Nebulas. Planetary nebula, which is kind of a misnomer.
Yeah. Long ago, when people like Charles Messier and some of his colleagues were looking at these objects, they saw these fuzzy little things that were some of the blue-green color to them, and it kind of looked like Uranus. And so they kind of resembled a planet, but they obviously were not planets. And so they got named planetary nebulas, even though they have absolutely nothing to do with planets. This is a little confusing. But that's the terminology we use.
Exactly. So this nebula is kind of another nearby nebula. This is kind of was it Vesepula, or is it or Sagitta? It's in Sagitta, I think. The Dumbbell. So this is the Dumbbell Nebula. So that's Sagitta is the arrow, which is kind of in the area of Cygnus, very close to where.
Yeah, right underneath Cygnus.
Yeah. So now you can see the exposures are starting to build up again on this picture now here. And this is some people also call it the apple core nebula. So you can see the bow shock, basically, when it started puffing off its outer layers. A lot of the gas, adjusting the image here. There we go, comes back. A lot of it's going in this direction here, and this direction here, and not as much over here. And some scientists theorize that has something to do with the magnetic poles of the star and the way the star is facing. That's the shape that we see from Earth. And again, in the center, you have a white dwarf star. And this nebula actually comes up pretty good even in an eyepiece in your telescope. If you're at a dark sky site like Jenny Jump, where our observatory, we have a big 14-inch telescope in Jenny Jump State Park. Up at United Astronomy Clubs of New Jersey, one of our telescopes is up there, and it's one of many. Sorry, I lost my train of thought. So you can see on this end here and over here, you can see some detail of this bow shock. It is, a little bit more advanced than, say, the Ring Nebula. The Ring Nebula that we just looked at is much more condensed than this particular, nebula. Again, this is another example of what could happen to our own sun at the end of its life. Again, it will condense, it'll let go of its outer gas shell layers and then condense down into a white dwarf, the remaining parts of it. And so that white dwarf will have ultraviolet radiation, which will illuminate the shell. And so all sun-sized stars are kind of doomed, quote unquote, doomed to this kind of fate. The stars that will live longer are these small red dwarf stars, and they can live for tens of billions of years, or 20 billion years, or for even longer, depending on if it's a really low mass star. It can live for some of the ones that are in some star clusters now are 10, 11, 12 billion years of age, and they can go on even longer than that. Kevin, how you doing on Stellarium? Did it come back?
Yeah, I think it's good. I was going to suggest that talking about stars dying is a little depressing. Let's talk about something more positive, like how stars are born. Let's look at. I guess you want to do a star cluster next. You do like M37 or.
Yeah, I could do that. Or do you want to start with M42 to see where they really start?
Well, okay, yeah, let's do that.
Okay.
So let me,
and then we'll go forward from there.
Yeah. So yeah, let's start out with, or start at the beginning here. Hold on a sec. Let me share my screen again and get Stellarium up. There we go. So you should be able to see the eastern sky at this point. As we face east, you may notice a very famous constellation. Constellation Orion is in the eastern sky now. And you can recognize Orion by looking for 3 stars all in a row. And sure, there's lots of places in the sky where you could probably put 3 stars together, but the ones I'm thinking of are very close. And this time of year, as Orion is rising, the 3 stars are sticking almost straight up from the horizon. So you got those 3 stars. And zoom in here just a little bit. And you can see the 3 stars all in a row, kind of right there. So this is the belt of the famous constellation of Orion. And so actually, let me put the kind of outline of him here. When most people look at these stars, they imagine them as a stick figure. He doesn't really have much of a head, but there's some stars up here that make up Orion's head. You've got 2 bright, really very bright stars that make up his shoulders. He's got 2 bright stars that make up his legs or his knees. and you've got the three stars in the belt there that make the three stars that make up his belt. And so he's usually thought of as a stick figure, a figure of a man there in the sky. To the Greeks and Romans, he was the hunter, Orion, the great hunter in the sky. Though different peoples had different ways of imagining these stars. The Egyptians thought of this as Osiris, the god of the dead. And so a different way of looking at these same stars. In fact, actually, one of the most interesting ways of viewing these stars actually comes from the New World, the Mayans, the Mayan peoples who lived in Central and South America. They didn't think of these stars as a man at all. They took these three stars at the lower part of Orion, the lower half of Orion. They took these three stars, this triangle of stars, and they imagined them as hearthstones. If you don't know what a hearthstone is something that you'd put around a campfire. And so they imagine this as a fire that you'd have, a cooking fire that you have in the middle of your home. And, that's a very important place to most people. Just like if you go to have a party, where do most people end up? They end up in the kitchen, right? Everyone's standing in the kitchen talking. And so the same thing happened in Mayan households. Everyone would gather around the cooking fire. And so these three stars represented not only the three stars, the three stones in the home, the Mayan home, but they thought of them as the hearthstones of the universe. They thought of this as the center of the universe. And if you look at the very center of that triangle, you notice that there's some smoke from the fire, the cooking fire. But if you zoom in closer to it with a telescope, a modern telescope, you'll notice that it's not fire, it's not smoke, it's an extremely large and close by nebula. And so this is known as the Orion Nebula, named after the constellation. And Mark is going to show you a close-up picture of this object, which is really very popular with amateur astronomers. So let me stop my share, and Mark, if you could show us the Orion Nebula, also known as M42 in the Messier catalog.
So first I'll share a nice still shot that I got of it. Again, this is out of the 14-inch telescope. And you can see it's kind of close up. It's filling up the entire screen. And we might wind up coming back to this particular picture again in a few minutes. But I will go back and also show you the video. But we'll take note of these little stars here in the center. These are called the Trapezium. Trapezium are stars. Again, all these stars that you see in this area here are actually born out of this cluster. Their illumination is kind of lighting up the gas cloud. You can see kind of going off in this direction, and very faintly down and over here too. So it actually it spills off the picture here and here, but this is all gas and dust. These are places where stars are actually being born. And our own solar system was born in a gas cloud, very similar to this one. So this is kind of where, picture back 4.5, 4.6, 4.7 billion years ago, our stars, our star and companion stars were being born in a nebula just like this one here. So I'm going to use that image here and start the stacking build up. But you can see these are going to get blown out real fast once the image starts stacking, because these are actually much brighter than the rest of the nebula. So you'll see these kind of get bloated in a little bit while the image starts to build up data. And you can see the orientation changed here because it was in a different part of the sky while I was imaging this one here. So you can see, the image is blown out a little bit. And this one here is with the 8-inch telescope. As I try to play with it to try to get the best image. Right there is pretty good. Oh, maybe I'll stop right there. So that seems to be where it got really detailed. So if we look at this, this cloud of gas and dust, this area here where the trapezium is now was actually completely filled in with gas and dust. And so what's happening here? A couple of things are happening. In the past, that gas and dust coalesced to start forming these stars at the center of this nebula right here. And then after these stars ignited, anyone who's ever heard of the solar, our own sun has a solar wind, and that particular solar wind enacts on the gas and dust and pushes it out. So what does that do? Any stars, in the center of here, there may be they may also have their own planets and solar system at the trapezium, but any other stars in the vicinity that haven't formed yet, they're going to struggle in their formation because that gas and dust is already being blown away. Now, stars further away out over here will be able to, they'll be able to form more planets because, the solar wind from those stars hasn't blown out the gas yet. So what happens over time? As the stars form, they absorb, and planets, they absorb this gas and dust, this primordial material, some of which forms rocky planets, some of it forms gas giants, some of it forms other stars. But once each star's solar wind, enacts on the gas, it pushes it out. So any planet formation has to really start and get underway before the star ignites. Because once the star in the locale or stars nearby ignite, it's going to enact on that gas and dust and blow it out of the reach of that particular solar system, and they won't have any planets, or it'll be limited to the planets that had just formed. So interesting thing going on here is, the takeaway here. This is a stellar nursery. Stars are being born here. Planets, solar systems. We could look back in time when the Earth was a newborn, and there was a lot more debris in the solar system, both rocky bodies, asteroids, comets. All of that is happening now. Impacts. So it's building stars, building solar systems, except they're much further behind than us in their evolution. They're at the very beginnings right now. Is there any questions? I'll stop this and go back, unless you want to take it, Kevin.
Well, by the way, the Orion Nebula is about 1,300 light years away from us. So you're looking at something that's about 1,300 light years away. And Mark mentioned that there are stars forming here, and in this area there's about 700 stars in various stages of formation here. So it is really kind of this star factory. It's churning out stars here in the constellation of Orion. And so a very interesting object for astronomers to look at, and it's very pretty for amateurs to look at. It's easy to spot in a small telescope, but it's bright enough that you can even spot it in binoculars if you've got a pair of binoculars there. Right. So there's the famous Orion Nebula. I'm trying to think, Mark, what do you want to do next here? Do you want to move on to a star cluster?
Oh, yeah, we can pick a cluster, perhaps the Pleiades are nearby. That's a good
one
to start with.
The Seven Sisters, that's real easy to find. Let me show you where it is, not too far away from where Orion is. So let me share my screen once again. And so I pull back and pull away and look at Orion once again. So here's the constellation of Orion. And if you look, if you're facing the eastern sky and you see where Orion is, if you go straight up above Orion, where Orion is, you run into the constellation, run into a bright star here, bright reddish colored star called Aldebaran. You've got actually two red stars here. You've got one in the shoulder of Orion called Betelgeuse, and then you've got Aldebaran, this red star here. Aldebaran is the glaring red eye of the constellation Taurus. And so this is Taurus the Bull. And you can recognize Taurus by this big V shape of stars. That's the head and the horns of the bull. And you can see the bull is kind of charging towards Orion there, and its red eye is right there. So there is Taurus. If you look on the shoulder of the bull, you'll notice that there's a little bunch of stars here. And that's the star cluster we're going to look at next, known
Yeah, but
as,
we can't see that. It's kind of blotted out. It's kind of
well, I'll zoom in here a little bit. We've also got the moon.
We see Orion right now. We don't see the constellation of Taurus.
Taurus is on the very
God,
top of the screen. It's kind of half.
I don't understand what's happening here. I think I'm having some computer problems here.
Do you want me to open Stellarium and you narrate?
I guess so. I don't know why this is.
Yeah, let me do that real quick. Oh, you got it.
No, it's gone. It's
gone. Okay.
Sorry.
Give me a couple seconds.
Call it up for me. So this is the star cluster's name is the Pleiades, and it's one of the most beautiful star clusters in the nighttime sky. And long ago, when before there were telescopes, people could look up at the sky and they could see, if you had good eyesight, 5 or 6 or 7 stars here. So that's how it became known by its nickname, the Seven Sisters. And so those are the famous Seven Sisters, otherwise known as the Pleiades. And so we're going to put up here a little map that will show us where the Seven Sisters are. Very, very easy to spot usually. All you have to do is face the eastern sky this time of year and look up above Orion, and you'll see this fuzzy little spot there in the sky, and that's where you'll see the Seven Sisters. It's a big enough cluster that it's really easy to spot in binoculars. In fact, actually, binoculars are probably the best instrument to use to see them because it's a big cluster. And so, yeah, so Mark's got the constellations up there.
We have Orion.
Yeah.
There's Aldebaran is Taurus, what we were looking at before, right?
Yep.
Taurus the Bull, and we're gonna.
Yeah, there's the moon there. That's where the moon is tonight.
Right. Yeah.
Not too far away from the Seven Sisters. Is just to the left of the moon tonight.
Oh, there we are. It's the moon's blotting it out. Okay.
Yeah. So there it is, right there. So there's the famous Seven Sisters. It's relatively close by to us, about 440 light years away. And it's got quite a lot of stars in it, though, even though we call it the Seven Sisters, there's a lot more than 7 there. If you look at it in binoculars or a telescope, it's probably about 1,000 stars in this cluster. Mm-hmm. And it's a relatively young group of stars, probably about 100 million years or so old. And so relatively close and really a very beautiful object to look at. And Mark, I think you can show us a close-up view through one of the telescopes. I think, is this from the 8-inch telescope?
This again is the this was actually a little refractor, a short refractor, it's a wide field,
small telescope. So this was a small one,
but it serves a purpose here.
Yeah. We also, I see in this chat, we also have a question about meteor showers, and so we'll
go ahead.
Talk about that. We'll talk about that in a moment. But let's look at the Seven Sisters here first. And so. Yeah, this was taken with a small telescope, and so there you can see some of the stars of the Pleiades.
Right. So this is a little wide field telescope, which is similar to the view binoculars would give you. And believe it or not, a pair of 7 by 50, 10 by 50 binoculars often gives you the best view of this particular what you call it, asterism. So the really cool thing about that, Kevin was saying this is about 100 or so million years of age. It's a long time for us, but for as far as stars go, these are juveniles. These are, maybe call them infants, but they're in the juvenile stage of their life right now.
Yeah, I think they're still tweens or teens at this point.
Teens or tweens, yeah, right.
Because they're not infants, you know. They're not like the Orion Nebula, which those really are infant stars.
Those are
in some
infants,
cases. This is a little bit older cluster, and
Right.
so it's a little bit further along in their life cycle.
But for the most part, it's exactly what Kevin said. They're further along in their life cycle. So what do we see the absence of compared to this in the Orion Nebula? Anyone have any idea? You know, what do we see? What did the Orion Nebula have that this doesn't really seem to have much of? There's a little bit of what I'm about to talk about, but does anyone have a guess what's missing?
I have a guess, but it's probably way off.
Oh, go ahead.
My guess is that this one probably it was made by a older I had the name of a thingy, but it was like I had the name of what it's called, but I forgot it. But it's like oh yeah, a neutron star residence. I think that this one was made from a neutron star residence much recent than the other stuff.
No.
Yeah.
This a neutron star is like the end cycle. You would
when
have
we were,
that.
when we were looking at the Vega Nebula, really
Right.
a neutron star would be more related to something like that, where a supernova has taken place. And sometimes after a supernova, what can be the leftover stuff can be a neutron star. So that's the end of the life, the other end of the life cycle. At the end of the life of a star, that could happen. It could turn into a neutron star. That's not related to the younger stages that we're looking at here.
Right. So if anyone else has a guess, I'll entertain that. If not, I'll tell you. Anybody else? Okay, so what we were just looking at previously was the Orion Nebula, and it had stars within that. The difference between this object and the Orion Nebula, this, we went back 100 million years in time. This would be surrounded by a lot more gas and dust than you see now. And so the stars have either used up their gas and dust and they've coalesced and formed stars, solar systems, planets, or they've, once they've ignited, they've blown off the gas and dust into interstellar space and it's dissipated, whatever's left. Hi, Bear. I have a cat here. So what we're seeing here is the next stage. So what happens what's the difference between this and the Orion Nebula? Kevin was saying, yes, they're in their tweens. They're in their, well, they might be your age, 7th and 8th grade, so to speak, or going into high school, that think of it that way, in that sense. So they are now spreading apart as the galaxy spins. They're held together by some gravity, but not enough to keep them from drifting apart from one another. So these are their siblings are slowly drifting apart. If we were to come back and visit this again in another 100 million years, these would be spread out and we would have a tough time finding them even. And we're still searching for our siblings that were in the stellar nursery with our own sun. We still really can't identify those stars. We have some, possible hunches that, maybe some of the stars in the Big Dipper could be related to that. Maybe not. But those are kind of, speculative at this point. So once they really spread out, it really becomes hard to trace their motions back at that point. After they've gone around, the galaxy has pulled on them and it's gone around an orbit or two around the galaxy. They've really spread out at this point. So here, they're leaving the nest at this point. They're getting to that point. They haven't quite left the nest yet, but they're drifting away. So they're going out. They've just gotten there. their driver's license, they got their new car, they're going out and exploring a little bit, but they still live home with mom and dad, you know, kind of thing. But you know, just giving an analogy there.
Okay, well, I think we want to move on to another object. I think we should, speaking of, since you mentioned it, you mentioned galaxies, let's move on to a galaxy. But before we do that, and while Mark is setting up his video for that, we did have a question in the chat about meteor showers. And Isabel asked about, is the Geminids where the shooting stars are coming from now? And yeah, that's you may have heard in the news that the Geminid meteor shower peaked yesterday morning, actually it was. And yeah, if it were clear out tonight, you would still might see a couple of shooting stars, quote unquote shooting stars, coming out of the constellation Gemini. And so yeah, these meteor showers occur because we have comets in our solar system. We have these icy balls we call comets, and when they get close to the sun, they heat up, they release gas, they release dust. And that dust, once the Earth will occasionally plow through some of that dust, and those little specks of comet dust hit the Earth's atmosphere, they burn up, and you see a meteor or quote unquote shooting star. It's not really a star, it's really a speck of dust. And so the Geminid shower is really, really good. One of the best of the year. And it's one of my favorites because it's active all night long. You don't have to wait till early morning hours usually. But this year we had a little bit of trouble with the moon. The moon was a little too bright during the early evening. But and next year too, I think the moon is not really that favorable. But the following year after that, I think it's 2023, in the middle of December, it'll be moonless or virtually moonless night, and you can watch meteors all night long. So it's a really nice shower, and so it's very good to look for. By the way, though, keep in mind that meteorites are a little bit different. Actually, Mark, could you stop sharing for a moment? Because I would like to see if I can hold up something to the camera here.
Sure.
Let me see if I can show this to you. Actually, get Mark off the screen here. And I don't know if you can see this, but
Cool.
I have in my hand here an actual meteorite. And this is not something that you would see from a meteor shower, which kind of is a little confusing to some people. You know, if you have a meteor shower like Geminids, you know, can't we just go outside and look for meteorites lying around? Unfortunately not, because the Geminid meteor shower is little specks of dust from a comet. This, on the other hand, is not from a comet. It's a chunk of rock from an asteroid. And so this is a little piece of an asteroid that came down in Arizona about 50,000 years ago or so. And so it's simply known as meteor crater or Barringen crater. And this was found in Arizona, this little speck of iron. Well, there's an iron meteorite from Arizona. So this once was part of an asteroid. And those can come down too. And those are not really related to meteor showers. They come down all the time. They just randomly, pieces of junk will come down. And we call them meteorites. And they're kind of fascinating objects, can tell us a lot about planets and the early parts of the solar system by studying them. So just that was a good question. That was a good question, Isabel, about meteor showers. There is another meteor shower coming up very soon, but it's a little tough to view. It's called the Quadranted meteor shower, and that happens usually early in January, usually around January 3rd or so. But it's a tough one to view. It can be sometimes strong, but it can be tough to view because it's very short. It's very short, very brief meteor shower. And sometimes we're not facing the right direction to get a good view. And so it's a tough one to view, but it is coming up soon. You might hear about it. So let's move on. Mark, you want to show us a galaxy, right?
Oh, so before we do that, so that's the radiant of the Geminids.
Right.
If
There's the Geminids, right? Yeah. Constellation Gemini, which is, we didn't point it out, but it's just over the shoulder of Orion. So it is up in the eastern sky. You look for Betelgeuse and then look off to the left. That's where the twins are, the Gemini twins. You can imagine these stars as two stick figures there in the night sky, and the Geminids come from near the head of one of those twins. And so that's a Geminid meteor shower.
Right.
But we want to move on to a galaxy. And so Mark is going to change our view here so that we're looking towards.
We're looking almost way up high now.
Yeah, this time of year it gets up high in the sky. You're looking almost overhead. And you've got two constellations really here. One is Pegasus, and the one we're going to focus on is Andromeda. And so you've got 4 stars there that make up the body of Pegasus, the flying horse in Greek and Roman stories. But we're going to zoom in here onto this kind of big V shape of stars known as Andromeda. And on a very clear, dark night, if there's no moon in the sky, you might see this kind of fuzzy little ball of light in the nighttime sky. And it's kind of amazing that you can see this because this is actually another galaxy. And it's named after the constellation Andromeda. It's simply known as the Andromeda Galaxy M31 in the Messier catalog. And this gives us a pretty good idea of what our own Milky Way looks like, because it's has a similar shape to our own Milky Way. And if you zoom in, you can see that Andromeda is kind of flat, like a pizza pie or a pancake. And it has a kind of spiral structure to it. It's known as a spiral galaxy. The Milky Way and Andromeda are both spiral galaxies. So you get this kind of pinwheel of stars. And in this case, it's the edge of it is almost pointing towards us. And so we're seeing a kind of elongated view of the galaxy. So this is a big collection of gas and dust and stars. That's what a galaxy is. And this is located about 2.5 million light years away from us. So that's pretty amazing. Something that is bright enough, it's big enough and bright enough that we can see it with the naked eye. You don't even need a telescope. If you have dark skies, you don't need a telescope to see it. Here in most parts of New Jersey, you need a pair of binoculars to spot it, but it is visible. You can see something more than 2 million light years away. You can see with your eye. That's pretty amazing. And in a moment here, Mark is going to put up an image that he took with one of his telescopes here.
And so I can find. All right, I'm going to try to share that again. Why are you not coming up?
And if anyone has any other questions about galaxies or stars, while Mark is looking for his video, feel free to ask.
Oh, that's why. Okay, so I'm going to. Reload that. Hi, Bear. Yeah. Okay. Let me get back to. Now it should work. Ah, there you are. Ta-da. Okay. So here, the image is just building up right now. I had to mess with some settings here. So again, this was with a littler telescope, but we used a smaller telescope because you can get the entire galaxy in. There we go. Now it'll get better at this point. And there'll be something interesting that happens here in a little bit too, that you'll notice something happens to the image. But here it is building up. This is about, these are 30-second exposures. No filters or anything like that, no light pollution filters. So this is just how it comes out. Small little refractor, and you can see Andromeda, right? You can see the spiral arms coming out here, and it's an angle to us. And you also see 2 other fuzzy objects here. So this is M31, Messier 31, 31st image that Charles Messier discovered in his catalog, or cataloged anyway. But then he started to notice there's another fuzzy feature. This little fuzzy feature here, M32. And then this is Messier 110. So this is the 110th 110th object in Messier's catalog. So the cool thing about this is it kind of mirrors our own solar system in a way. We have a large and small Meningelic cloud. And the other thing to note, in about 5 billion years or so, the Andromeda and the Milky Way will merge together. And will be called Milkopedia or something along those lines. So they won't have spiral structures anymore. And at that point, you know, they will look very different. And star formation will go under a very large period of star formation when that happens. And it's very unlikely that our solar system will collide with another one, but you may have some turbulence during that time. Ironically, at that time, too, will be the same time our star is in its red giant phase near the end of its life. You have anything else to add, Kevin?
No, but we had a good question in the chat. How many objects are in the Messier catalog? And about 110. About 110 objects were put into the Messier catalog, both by Charles Messier and one of his assistants. Found 110 objects in the nighttime sky with a small telescope. And so one of the things that amateur astronomers sometimes like to do in the spring is they like to have a Messier marathon, and they try to spot all 110 objects in one night, and they got to go all night long and try to spot everything in the catalog, which is I've never actually, Mark, have you ever done it? I have never done it. I've never been up all night.
Oh, once I did it. Yeah. And that's when I went up to upstate New York. What was the name of the state park?
You need some dark skies.
Yeah, it was Lake Taconic State Park. It was pretty dark.
Oh, right. Yeah, you need a really good
Taconic.
view. Need a good view of the horizon, and you need.
Yeah, I brought my 12-inch telescope, and so the way you do that is you start at as soon as it gets dark. And there's the strange thing happened. I'll talk about that in a minute. You can see these little lines over here. So the way you start a Messier marathon, you start as soon as it gets dark. You start in the western part of the sky. You go through everything. You want to get everything before it sets, because then it disappears behind the horizon. And then you work your way east across the night. And then by dawn, you finish up the catalog. I've done it once. I won't do it again anytime soon, but I'll do a bunch.
So explain what those streaks are in the image there.
Right. So I'm going to back the video up a little bit, just a tiny little bit to show this. Okay. It's about to come again. So as it's going, it's stacking exposures. So these are 30-second exposures, one at a time, stacked upon each other. And then it goes from nothing to all of a sudden these streaks. Does anyone, before we end tonight, there they are. Does anyone want to take a guess at what those things might be?
UFOs.
Good.
Are they comets or stars or light reflectancy within the galaxy or atmosphere?
Much closer to Earth. It's outside the atmosphere. Much closer to Earth. Very close to Earth, but outside our atmosphere.
The moon?
So does anyone, people have heard of SpaceX and Elon Musk, I'm sure, and they're putting up these Starlink satellites that are supposed to give internet to like rural areas and whatnot. So this got a lot of astrophotographers complain about it because they ruined the nights. They ruined their photographs because they kind of like photobomb their astrophotos in the middle of their imaging session. So these are actually what look like 3 of Elon Musk's Starlink satellite constellation going through the image at this point. Yeah. And you only tend to see them. Go ahead, Kevin. Sorry.
Oh, Max pointed out that he says the ISS, the International Space Station, that can happen too.
Right.
But the International Space Station is much, much brighter. In fact, the International Space Station, if you get a real nice pass, can be as bright as Venus. And so very bright and moving through the sky. So that can happen too. And it would look similar, but just much brighter.
Much brighter, yeah. So yeah, that's what you're seeing are these artifacts. And you know what happens that if you're within an hour and a half of sunrise and sunset, you know, if it gets really dark, the sun has set for us, but high up, you know, in orbit, these satellites and or the space station reflect the sunlight in the sunset coming over the horizon. So they're still catching the sun because they're much higher up than we are, even though now we're in the Earth's shadow. And so that's why these are lit up. If this were midnight, 1 in the morning, these may have gone unnoticed because they wouldn't be reflecting any light. So that's the difference here. So it's you go ahead, sorry.
Well, I think we should start to wrap it up, but we do had one question that, speaking of Max, Max asked a good question in the chat about the distance to Andromeda Galaxy. And he was asking about when is it at its closest within the past 10, 20 years. Remember, this is not decades we're talking about. We're talking about billions of years. And so right now, as we mentioned, it's about 2.5 million light years away from us. And so 2 billion years from now, it'll be half that distance. So a little over 1 million light years away from us. And then in 3 billion years, talking 500,000 light years away, and so on. So you're talking billions of years before the Milky Way and the Andromeda Galaxy close to each other, you know?
Yes, right. So the light that you're seeing is 2 million years old. That's how you're looking back in time 2 million years. You know, it's actually much closer to us than it was 2 million years ago. But the speed of light is moving much faster than the galaxy is moving towards us. So, you know, as we see it now, it's actually much closer, and it's somewhat larger, and you know, compared to what we actually see it now. But that light hasn't reached us yet, so it's just an interesting thing to talk about.
Yeah, and you know, as Max points out, it is kind of like time travel. When you're looking up at the nighttime sky, you're actually looking into the past in a way, because that's how long light takes for light to reach us, you know. And so when we look with some of our biggest telescopes, you're looking at objects that are, you know, 12, 13 billion years in the past, you know, so you're looking back in time in a way. So actually turns out to be very useful because we can see things that we wouldn't ordinarily be able to see, you know. So it's a very useful thing that we can do with the nighttime sky. So yeah, I think we should wrap it up for tonight. And so thank you, Mark, for your imagery there. And Daniel, you want to say any last words here before we wrap it up?
Thank you again for this, you know, incredible wealth of knowledge. And I look forward to when we can get outdoors with actual telescopes and actually see what's happening right before our eyes. So we will continue to schedule that and wait patiently for that event to actually take place once Mother Nature cooperates with us. Yep.
Great. If you'd like to know more about our club, you can go online, check us out at njastro.org, or you can look us up on Facebook, and we have some videos for our previous events available on YouTube. We have NJAG Online as our channel on YouTube, and you can check those out as well.
Yeah, some really good videos on their website. So if you're interested in seeing more or listening to some of their discussions, please go there and check them out. There's a wealth of stuff